Hello, good evening, student.
Good evening, everyone. I hope you all are doing well. A very warm welcome to all our respected speakers and dear participants. On behalf of Time Fireto, Biomed Private Limited, and AdGrow Foundation, I welcome you all to day 6 of our 1 week hands on workshop on network pharmacology, molecular docking, pharmacokinetics, and molecular simulation. Thank you all for joining us once again. We hope you have been enjoying the workshop and learning something new every day. Today's session has two parts. First, we will have a doubt clearing session where participants can ask questions related to network pharmacology, molecular docking, pharmacokinetics, and molecular simulation. After that, we will continue with the hands on practical session on pharmacokinetics. We encourage everyone to actively participate and make the best use of this opportunity. Now it is my pleasure to invite our respected experts, Mr. Dr. Ghanshyam Parmar, Mr. Bhuvesh Vania, Mr. Jai Mukesh, to join the doubt clearing session. Dear participants, this is a great opportunity to clear all your questions. Please feel free to ask your doubts either by raising your hand or through the chat box. Respected speakers, the platform is all yours.
Good evening, all of students. I think I am audible. Due to heavy rain at Rajasthan, it may be disturbed network issue. So please cooperate. So
In your message, you are audible.
yeah, so one by one, please ask your question. Uh, Yesterday, one one student asked one question. If we have lots of gene, so how can we interpret it and perform in cage analysis? तो क्वेश्चन का आंसर यही है कि अपन को नेटवर्क फार्माकोलॉजी की ही इसीलिए है कि ताकि साइटो एनसीए से टॉप नेटवर्क पता चल सके अपन को, और उसी नेटवर्क को टॉप नेटवर्क को अपन को रिप्रेजेंट लास्ट में आपको कंक्लूजन के रूप में लिखना है. सो वी कैन यूज approximately 1 2 3 4 5 top cyto NCA gene, and then particular gene to we will dock to particular ligand and particular protein PDB ID. Okay. Next question. Second question. Yes. So if your answer is first, my question, why we perform network pharmacology? Because of network pharmacology is done to understand how drugs and gene and protein, also as well as disease, interact in complex biological network. It used computational model to predict how a medicine or herbal formulation impact multiple target and pathways simultaneously. That's why we perform network pharmacology. Okay, so if you have lots of ligand and multiple diseases, so how to finalize what particular compound will use in particular disease? That's why we perform network pharmacology. Okay, and Sivraj, your question: what is correct workflow to write network pharmacology? Okay, I'm showing one graphical abstract with you. So uh, I have one graphical abstract. This one is graphical abstract. You can see here various types of databases. You can see Gene Card, Drug Bank Online, Gene Card, Drug Bank Online, NCBA databases, and then we found out Originum vulgaris targets and Alzheimer disease targets by different pathways and different of gene card, uh, drug bank, any types of computational techniques. Then we found common targets with the help of many tools, and then the common target we copy and put into a cytoscape in a gene mania plugin. Then with the help of cytonca plugin, we find out top 10 network and top 50, maybe top 5, top 10, and then those top 10 targets we copied and again we put into PantherDB. PantherDB is a platform, free platform, and put into PantherDB, and we will check how many pathways are involved in particular gene. Then we check pathway. Later on, pathways ID, click on pathways ID, and we checked in KEGG analysis, uh, KEGG analysis pathway. So this is whole uh, is the graphical abstract type of performer, and then the top targets like APP, EGFR, cancer like gene. Click on top target and dock to a particular ligand, particular compound. Okay, so you will first you will check protein molecular docking. So maximum showing molecular docking, binding efficacy, and then bind to our protein PDB ID, and then we perform molecular docking and finalize by simulation method. Okay, second question. If I want to I want to study two different pathway. Okay, if you want to study two different pathway, so you have to choose both pathway, like Alzheimer disease pathway and Parkinson disease pathway. So for copy your protein and search in cake analysis pathway. So you will find out your pathway. Again, sir, how we can use gene mania in cytogenesis principal protein? Uh, I already told cop- copy your 8 common target and put into a cytoscape in a gene mania plugin. Then click on app, and click to cyto NCA results. So you will find a top protein, top gene ID, and correlate to your Homo sapiens gene name. Okay, so you can check how to perform. So this is cyto NCA. Go to a firstly go to a Google and search Gene Mania. Gene Mania plugin. Gene Mania plugin. Click on Gene Mania plugin and download it. Download Gene Mania. So automatically it will comes in a Cytoscape software. Similarly, search Cyto NCA. Cyto NCA. Cyto NCA and click on download. Here you can see here you can see download. So click on download. It automatically comes in a Cytoscape software. Then you can perform your task. Okay. Any other question? Firstly, go in a Cytoscape, then go in a Cytoscape, automatic show Gene Mania plugin, and your common Venni tool gene put into a Gene Mania plugin. Click on Homo sapiens human and then put here your gene, like your gene, base gene, base 1 gene, APP, your like a cancer gene, EZFR. So maybe multiple types of gene and search. Search. This gene are showing and export to here and make one folder. Export to here and make a folder. Then go to apps and click Cyto NCA, open, click on betweenness, closeness, and degree. analyze. You can see here your all gene. So top gene showing APP here. Amyloid precursor protein. Second one is cancer gene here, EGFR. Third one SHC1. Fourth one B, ABPP1. So export to here and create one folder. Then check what is your top gene. You can change layout to here. Click on degree and shortcut. Okay, you can change style to here, shape, different type of shape here. Click on gene and change your gene shape. Okay, so click on gene and change your gene shape like this. You can change gene color, label color here, fill color here. So click here and you can change. Okay, so you can change color of gene. Okay, then top 5-10 targets put in Panther DB. It's very simple. Okay, so go to gene list analysis and put your top gene. So what's your top gene? APP. Second one. Second one is, click on second, EGFR. Okay, you can see here EGFR. GFR. Okay, click on organism, Homo sapiens, and function by check by pie chart. Function check by pie chart. So you can see molecular function, biological process, cellular components, protein class, and pathway. So check Alzheimer's disease amyloid secretase pathway is showing here. And then go to KEGG analysis. Directly you can search KEGG analysis with your protein name and gene name. Okay, so what's your gene? Your gene is APP, your gene is EGFR. Okay, so your disease pathway is Alzheimer's disease. It may be cancer. Which type of cancer? So cervical cancer maybe. Okay, so cancer Click on cancer. Because of EGFR related to a cancer. So open this map ID. And directly search your protein name in KEGG analysis pathway. Okay. So you can check where is EGFR and you can cite in your paper which pathway are following your gene. Okay. You can see here TP53 is related to your cancer. So various types of genes are available here and check where is your gene and which pathways are following. Okay. And download to here and cite in your paper. KEGG analysis. Okay. Next question. Yes. Degree basis we selected because degree is showing the interconnection relationship with the help of cyto-NCA. We will check top genes. Okay. Alzheimer's disease. Next question. Now so doubt classes are completed. Next today's topic was drug likeness evolution. How to prepare protein ligand complex. Okay. Protein ligand complex with the help of PubChem and any tool we will prepare. And this section discussion will be provided by Dr. Ghanshyam sir.
Okay, can I answer, sir, right now?
Yeah, sure, sure.
Yeah. So for complex, you can use Pymol, Drug Discovery Studio by BioVia. You can use this tool for MD simulation, complex simulation. Pymol would be the best one. You can use it for complex formation.
Okay. So your gene is here, APP gene, and you can search EFR is it needed. Due to network issue, it's taking some time. Okay, so Alzheimer disease are here, and you can see APP amyloid precursor protein. So network pharmacology now done.
Gansham sir, one question is there.
Okay, you are facing problem to prepare MD simulation study. It was showing that your file is not prepared correctly and contain heteroatoms. Okay, so while you might be not prepare properly the protein preparation file, okay, might be a missing residue will not be added by you. So in tomorrow's session, Mr. Jay will explain you how to prepare a complex and how to validate your file before running for the MD simulation. So tomorrow you will guide it entirely or perfectly. So you will not find any issue.
Sumit sir, now all topics are covered.
Is there any other doubts, or we can start the next session? Bhuvnesh sir, please start next session.
Okay. So first day I covered ADME prediction. ADME we will predict by ADMET tool, ADMET analysis. Again, I repeat how to perform ADMET analysis. Vishnu. Select your compound smiley like curcumin, smiley, curcumin smiley. This is your compound. I'm using compound only, not a plant. Copy your smiley and paste into a smiley and predict. Here is your result. Various types of software are available. This molecular weight, blood-brain barrier penetrability, and Swiss ADME we can use. Search your smiley and run. Here is pharmacokinetic profile. Okay, so you can see for formula, molecular weight, number of heavy atoms, okay, lipophilicity, drug likeness, medicinal chemistry profile, pharmacokinetic profile. Okay, now you can check to click here, so boiled egg. This drug can penetrate blood-brain barrier. So your answer is no, because showing your drug is here and here is intestinal tract and yellow color is showing blood-brain barrier. So this drug cannot penetrate blood-brain barrier. So if you want to study in a brain, so firstly cover to a lipophilic compound, then you can penetrate and you can prepare nanotechnology to and then you can use in a neuro related disorder and disease. Okay, so if you prepared any type of research paper, you should cite this photo in your manuscript and write here your compound name. Okay, second one, pharmacokinetic assessment is now completed. Toxicity profile. So already I told admit tool to predict toxicity profile. Earlier I presented all tasks how to predict toxicity profile. Okay, selection of potential drug candidate. Potential drug candidate we select firstly by Lipinski rule. All compounds should cover in a Lipinski profile. Then we check by cyto-NC result, and later on we used for molecular docking. Okay, first we select which genes are most top 10 targets are showing, and then top target to bind our ligand, and our ligand name is curcumin, maybe or maybe different, limonene, zeranol, quercetin. So bind to your ligand, your PDB. Okay, like your ligand name is curcumin and your PDB ID name your PDB ID name is 4AXA. So select your PDB ID and then dock to your ligand. Okay. So step by step, first we retrieve all plant compound, plant gene, and target disease gene. And then with the help of Veni tool, Alzheimer disease. With the help of Veni tool, we check our common pathway for common targets. Okay. So check, here is your common, and you can change all border, color, transparency, line, font. Okay. And then the common gene we will use in a Cytoscape Gene Mania plugin. Okay, so potential target we check by CytoNCA. Okay, so all topics are covered. Now, you have any confusion related to network pharmacology, you can ask freely. I think now you can do network pharmacology easy, in an easy way. All candidates, you have any problem related to network pharmacology, please ask freely. Okay. Now, Sumit sir,
Yes, sir.
I think all students get results and know about how to perform network pharmacology in an easy way.
Is there any doubt, or we can conclude today's session? You can ask freely.
And my last cake analysis comment is this: if you have lots of gene, so you should mention your pathway or particular disease, okay, in your manuscript. If one is showing APP and one is another is showing EGFR, So you should mention both pathway. One is cancer related pathway and second one is Alzheimer related pathway in your manuscript. Okay, student. लिपोफिलिसिटी यहाँ शो हो रही है लॉग पी. ठीक है, इसमें क्या है कि आपका ड्रग लिपोफिलिक है या नहीं है. योर ड्रग इज शोइंग लिपोफिलिसिटी और नॉट. You can check by a log P. If your drug showing lipophilic nature, it will be show better absorption in a brain and can penetrate blood-brain barrier. And you're showing, if your drug showing lipophilic nature in an intestinal, absorption will be good. Okay. Here is pharmacokinetic profile and gastrointestinal absorption is high. Blood-brain barrier penetration and permeable, no. Okay, so if this is enzymes, this is drug likeness, Lipinski, Gauss, and bioavailability score. If you want to cite in your paper, you can cite all properties in your paper. Okay, now I can, okay, if a compound doesn't show. No, if your compound doesn't show direct relation to that disease pathway, but indirect can. 1 minute. If showing a relation, then you will cite in your paper. If doesn't any type of relation, so how to cite in your paper? So firstly, direct relation to your gene and disease. Then you can write in your paper and it will be acceptance chance will be 100%. If not showing any type of relation, so how to cite and how to write in your paper, this is relation are showing. Okay, Vibhuti. Now I conclude today's session. Thank you, Sumit sir. Thank you, Ghanshyam sir, and thank you, students, for provided this wonderful opportunity in front of all international students and national students.
Thank you very much, Mr. Bhuvnesh, for today's excellent practical session on pharmacokinetics. We also extend your sincere thanks to Dr. Ghanshyam Parmar, Mr. Bhuvnesh Bania, and Mr. Jai Mukesh for taking the time to answer participants' questions during the doubt clearing session. Your guidance and support have made the workshop a truly valuable learning experience. I would also like to thank all our participants for their active participation during today's session. Before we conclude, I would like to remind everyone that tomorrow is the final day of our workshop. Please join us by 6:50 p.m. as the session will begin sharp at 7 p.m. Important announcements regarding the final assessment certificates session will also be shared tomorrow. On behalf of Thyme Phytobiomet Private Limited and Agro Foundation, thank you all once again for being with us today. We look forward to seeing you all tomorrow. Thank you everyone. Have a wonderful evening. Good night and Jai Hind.
Thank you.